Hey everyone, welcome back to the AP Precalculus series. So in this lesson, we are diving into one of the most important trigonometric function, that is the tangent function. So we will explore how it behaves, how the transformations, the general form of the functions, including all the transformation effects, and how to analyze its properties using real AP style reasoning. So grab your notes, graphing calculator, and let's master tangent together. So what is tangent function? We know a tangent ratio in a right triangle. We define something like this. Tan theta is opposite by adjacent, or else we can write sine over cos. Right? When theta is the right angle in the right angle triangle or on the unit circle. So tangent gives the ratio of opposite to the adjacent. It doesn't depend on the hypotenuse. And in many real life world problems, this tan is what we will be using as we are be aiming to find the hypotenuse. Right? Now let's learn its function form. Tangent function, the basic function will look like this: y equal to tan x. X is an angle, either in radians or in degrees. So the period of the tan function is not 2 pi. Like for sine and cos, it's 2 pi. But for cos, tan, it is 180 degree, that is pi radians. Domain is all real numbers, yes, except where cos theta is 0. Because this tan is a ratio function, ratio of two functions, sin x over cos x. So your denominator cannot be 0. Denominator is cos. It can be 0 at some points. So we have to reduce that. Like we need to neglect those points. So a domain has a restriction, all real numbers except where cos theta is 0. That is 90 plus 180 times n. So this is the thing, or pi by 2 plus n pi, where n is any integer. Right? And range is all real numbers. There is no restriction in its output values. Vertical asymptotes, yes. Whenever your denominator becomes 0, there is a hole, right? Or an, for a rational function I'm telling, but this is not a rational function, but still it behaves in the same way, right? So vertical asymptotes for a tan function is theta equal to pi by 2 plus n pi. These are the values we are excluding in domain. Those were asymptotes in your tan function. I mean the tan graph. Symmetry, yes, this function is symmetrical because it's an odd function. Tan of negative theta is negative tan theta. And y-intercept, it will cross the origin. These are all about the facts and properties or key features of the original parent function of tangent function. But you can do many transformation. Accordingly, we will adjust these parameters. Right? Now, graphing tangent function, you need some key values, key points. Like for sine and cos and all, we did 0, 30, 60, 45, 90, many key points. Here, we are taking 45 and the multiples of 45 as, because tan 45 is 1. Then tan 180 minus 30, 180 minus 45, which is 135, it's negative 1. And at 90, 270, it's undefined, and there will be an asymptote. There will be a discontinuity. When it becomes 0, 0, 180, 360. So, n pi, tan becomes 0. Odd multiples of pi by 2. Odd number times pi by 2, there will be a vertical asymptote. Right? And at multiples of 45, it's 1. So this is enough to sketch the tangent function. Let me show you how the graph would be. So here, when 0, tan is also 0, and it will be slowly increasing like in concave up manner. Like tan 45, it's 1, right? Suddenly when it reaches tan pi by 2, it will go undefined. There will be a rapid increase, as you can note it. Also, it will go till infinity. We can't define that. So there exists a vertical asymptote. And to the right of pi by 2, if you see, it's approaching negative infinity and it goes on and on. Like this, it crosses at pi, 0, pi, 2 pi, negative 2 pi, it crosses. So the midline is B, your x-axis. And vertical asymptotes, these are things. So its concavity changes between two asymptotes. If you observe, you can see a pattern of the tan function. So concave down increasing, then concave up increasing. It's increasing anyways, right? Now, Transformation of tangent function. We start with parent function y is tan x and you apply all the transformation parametrics as you see here, introducing a, b, c, d. So here in sinusoidal we use a for amplitude, right? But here it doesn't have an amplitude because tan, when you observe the graph, it doesn't, it's unbounded. That's so A will be a vertical stretch or a dilation factor. So when your A is greater than 1, absolute value of A is greater than 1, it's a vertical stretch. When it's less than 1, that is between 0 and 1, it's a compression. When A is less than 0, there is a reflection across x-axis. And period affecting factor is B. New period is pi by modulus B. I mean absolute value B. And as a factor, if you see of transformation factor, modulus B greater than 1, horizontal compression. And modulus B less than 1, it's a horizontal compression. Another word you can use shrink. And C, phase shift by C units. D, vertical translation. Everything is same. This is nothing new here. Like as we did for some other function like quadratics, many function, polynomial functions, exponential, logarithmic. The transformation rule is same. There is nothing new. And yeah, the word might be new. Instead horizontal, we will use phase shift. Yeah. Let's solve some questions. Identify the period vertical shift of the function related to y is tan x. So y is tan x means I know the period is 5. But what is the period of this? It's quite simple. You have to just look upon, here I go. Let me zoom this. So when you see here, I hope it's clear now. So just find the difference between two asymptotes. So it's every gap, like every box is scaled to units. So 2, 4, 6, this is, and this is 18. So the distance is the period, right? Because that is quite easy to me. If I go for any other points, like if I go for crossing x-axis, I won't get the perfect absolute one, right? So I choose vertical asymptotes. 18 minus 6 is 12, and hence the period is 12, right? Next, I need to find the period in vertical shift. Usually it will cross here, but this time it's here, right? It's in the middle between this and this. So let's see, 0 to 50, so each is 10. So between 0 and 10, just find the midpoint. That is where it is located, the inflection point, right? So that is your, that decides, that gives you a vertical shift. It's down 5 units, right? So vertical shift, the factor is -5 and you can say down 5 units, right? So that's simple. And now let me zoom out. Here we go. Question number 2. The graph of the function in the xy plane is given. Okay. H of x is a tan bx and a and b are constant. Find the value of a and b by looking at the graph. Okay. So a will be not affecting the amplitude here thing. So because we don't have maximum minimum. So let me find b, which is quite easy from the graph. So b is something I know, period equal to pi by b. Okay, what is the period of this graph? Previously I was using vertical asymptotes and I find the distances, consecutive vertical asymptote. But this time, finding vertical asymptotes is fine. So maybe this is the vertical asymptote and this is the vertical asymptote. I can do that, or I can just do with this time it's easy that x-intercept. So right, consecutive x-intercept you can pick and find the difference. So 4 minus 3 is the period. It keeps repeating its pattern after this length of interval. So period is 2 and pi by b. And this implies your b is pi by 2. Okay. Now your equation got fulfilled, like y equal to a tan pi by 2x. Right? How can I find a? So you can pick some point. It's only one unknown is A. If you see any notable point which is exact, that is better, like 0, comma 0 or 2, comma 0, right? In that way. So let me use this one, which is 1, comma 5. No, not 1, comma 5. So it's actually one gap is 2. So that 2 is divided into 1 by 2. So this is 1 by 2, comma 5. So I'm plugging in that. So 1 by 2, comma 5 lie in your function. Lies means, so 5 equal to 8 tan 5 by 2 times 1 by 2. So 8 tan 5 by 4. 5 equal tan 5 by 4. It's super easy value 1. So we got our A and B. A is 5 by 2. This is the way you can find A and B. Correct? So hope this helps. And now we are in the last question of our discussion. For the function y is negative 2 tan 1 by 2x plus 5 by 4 minus 1. Find the period, phase shift, and vertical shift. First, make sure it's in the problem. But it's not. Minus 2 tan, it's not bx plus c I want. So like b taken common out x minus c. This is the form I need. So I'm going to do that. Okay. So take 1 by 2 common. Whatever before your x, you have to take it common. X minus 1 by 2. No, pi by 2. And then minus 1. Okay, this is your A. This is your B. This is your C. This is your, okay, actually it's plus, right? Plus, and this is your D. Now find the period. Period is pi divided by, maybe I can do here. So A part. Period is pi by B. I think this is the B, right? 1 by 2. So pi divided by 1 by 2, which is right. Next part. Let's find phase shift. Phase shift is C, right? It's plus pi by 2 means phase shift left by, okay, if you see plus, actually this is x minus of minus pi by 2. Okay, that's why it's left pi by 2 units. Left by pi by 2 units, and as a factor, it's just negative pi by 2. Right. Last one, vertical shift, this is the 1D. So vertical shift down by 1 unit. Vertical shift, yes, it's minus 1 is a factor, and it implies by 1 unit. Right, this is part A. Right, now moving to part B, state the equation of the first vertical asymptote to the right of x is 0. So they are asking just the first, but I will tell you that there is infinite many number of asymptotes. Let's see how to find the general. Okay, so general asymptotes, let's find it here. So take the equation, and you know where the tan will go undefined, like the original tan, right? So where it will go undefined at pi by 2 plus n pi, correct? So that is where the vertical asymptotes will occur. So vertical asymptotes for y equal to tan x will occur at x is equal to pi by 2 plus n pi. Where n belongs to z. But my function is not that. It's something, so it's just only this thing of it. So instead x, you will put this half x plus pi by 4 equal pi by 2 plus n pi. And solve for it. Take the pi by 4 there. So half x equal to pi by 2 minus pi by 4, it's pi by 4 again, plus n pi. Then you multiply by 2 throughout for all the equation, right, for both left and right side. So x is equal to 2 pi by 4 will become pi by 2 plus 2n pi, where n belongs to z. Okay, this is general. Like I'm telling all the asymptotes in this one equation. But I need The first vertical asymptote to the right of x is 0. Okay, you can put n is 1 or n is 0, you can put x is equal to pi by 2. Let me put x is negative 1. X is pi by 2 minus 2 pi, right? Which is negative something, so this is left of 0. Okay, so this is n is equal to 0, so first, and it's positive, right? X is pi by 2 is the first vertical asymptote to the right of 0. If they ask left of 0, we'll go with negative 1. Okay. So that's it, but this is just a check I did to confirm it. So this is not useful to us. N is equal to 0 and x is equal to pi by 2. And yes, I have a bonus question, as you can see here. Take a screenshot, solve it on your own. Identify period, phase shift, vertical shift, and also find the x-coordinate of the first vertical asymptote to the left of y-axis. Right? So try this, and that's the wrap for this video. I will be with you the next episode very soon. Until then, keep learning, keep practicing. You can scan the QR code to join Let's Unbound student community. Thank you. Stay curious.